Okay, so number 5. Sine over cosecant plus cosine over secant. I know I need to work my way to 1, but anytime I see 2 fractions, I'm always trying to think about what can I do to push those together. So I'm going to find a common denominator. What's our common denominator for these 2 fractions here? Yeah, cosecant and secant, right? We have 2 separate expressions. We're going to have to include both of them as part of our common denominator. Okay. Next up, we have to balance each of the fractions. What's needed for the first fraction? Secant. So I need to multiply the numerator by secant. Second fraction was needed. Secant. All right, so it's still a little bit more ahead of us. Even if we try to push this together, we're not getting anything that can combine. So maybe what we can do is let's convert some of these to be in terms of sine and cosine in the hopes that the numerator will begin to kind of find ways to merge. Because right now, there's not anything that we can do there, right? So I'm going to convert secant to be, what can we convert secant to be? 1 over cosine, and I'll convert that cosecant to be 1 over sine. I'll leave the denominator alone. I'm hoping that the denominator in this form, let's just see what happens. Let's see what happens to the numerator over the other side. Okay, so sine over cosine plus cosine over sine. Well, maybe I can find common denominators within this portion here. So what's my common denominator? Yeah, cosine sine. Yeah, so the most tedious parts of these problems are just dealing with all these common denominators. So balance the numerators here. This first fraction is missing, between cosine and cosine sine, is missing a sine. Second fraction is missing sine to cosine, missing a cosine. So I get sine squared plus cosine squared. Okay, that's a good sign. We know that that's something that we can use identity with. And you know what? Let's go ahead and just convert the denominator to be in terms of sine and cosine as well, since everything's in terms of sine and cosine, and we're hoping that things will just clean up nicely for us. Okay, so cosecant is 1 over sine, secant is 1 over cosine. Okay, so this is what we have so far. We have sine squared plus cosine squared. All this is under 1 fraction. I can make that what? What's sine squared plus cosine squared? 1, okay. So I have 1 over dividing by a fraction is the same thing as multiplying by the reciprocal. Now this is, I can just have all this under one fraction, right? 1 over sine theta cosine theta. So I can multiply by the reciprocal, which is sine theta cosine theta over 1. So that works out nicely, right? We get those to cancel out. We're able to confirm there's a match with the right side equals to 1. Yes?
How do you get rid of denominator?
You mean from here to here?
Yeah.
Okay, so I made that secant into 1 over cosine, and I made the cosecant into 1 over sine. So really, this just became sine over cosine plus cosine over sine. And then I found a common denominator of cosine times sine. Oh, you're asking how did I, let's see, how did I get rid of this denominator?
Of the secant is.
Oh, okay, right. So cosecant and secant, I want to find a better match because everything in the numerator is in terms of sine and cosine. So why not also do the same thing with cosecant and secant? So I made cosecant into 1 over sine, and I made secant into 1 over cosine, which is really 1 over sine cosine. And then I took that and I flipped it to the top to merge with the numerator fraction.
All right.
Okay, number 6. Yeah, question.
So before I did so cosecant is the inverse of sine.
Oh, you just flipped it at the beginning.
Yeah.
Oh yeah, that is faster, isn't it? Yeah, that's much faster than the way that I was doing it.
Okay.
Yeah, so that works. Yeah, because sine, let's see, cosecant can flip up to be just sine. Secant can just flip it to be cosine, and we get sine squared plus cosine squared equals 1. Okay, so we didn't have to go through all this here. But this is still good practice, though. This is still good practice with common denominators. But yeah, thanks for talking about that. I did not see that connection there. Okay. Okay, let me just go through the problem from that perspective so that you guys can see number 5 again with this easier approach. Okay, so here's the easier approach to this problem here. I did not see it till now. Thanks for bringing that up, DJ. So cosecant can be rewritten as 1 over sine. And then secant can be rewritten as 1 over cosine. And then within each fraction, we can just push that up and multiply by the reciprocal, right? So this is really times sine theta. So I'm really having sine theta times the reciprocal, which is sine theta over 1. And then cosine times the reciprocal of its denominator. So now we're left with sine times sine, which is sine squared. Cosine times cosine is cosine squared. And that's equal to 1. Okay, number 6. All right, here, if we try to bring something up or convert, everything isn't already in terms of sine and cosine. So we know that we're just pretty much just going to have to find common denominators, right? I don't think there's a shortcut around that. So what's our common denominator for number 6? Sine cosine, okay. go through our balancing step. Numerator is missing, I'm sorry, denominator is missing a cosine. So I need to distribute a cosine through. Second fraction looks like it's missing a sine. So I'll multiply a sine through. Okay, so let me write that out here. We have cosine of theta times sine plus cosine. And then I'll pull the sine in front here, and I'll say sine theta. Okay, but at least I have common denominator, so I can push all this under one fraction. I'll just distribute all the cosines through, distribute the negative sign through, and see what we can do to clean that up. So distribute through. And be careful, I'm going to take the negative sine theta and distribute that through. So I'm going to have the negative tag along in front of the sine here. So cosine times sine. Plus cosine squared. Minus sine cosine. Plus sine squared. Negative sine times negative sine is positive sine squared. All over sine cosine. Okay, we're hoping that the numerator will just clean up very nicely for us. Let's see what happens. What do you guys see here? Good. Those go away. Good. Pythagorean identity, right? We have cosine squared plus sine squared. That's equal to 1. So we have 1 over sine cosine. Okay, let's go back and look at what we're trying to reach here. We're trying to reach secant, cosecant. Are we close? Yeah. We know that secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. So we basically can just flip them and turn it into.
Wouldn't it unfair if this sine squared if there would be negative sine squared?
So it was negative sine, but then we distribute a negative through.
Okay.
Yeah, so negative sine times negative sine gives me positive sine. So we're able to make that a positive sine squared. Okay, whenever you're ready, we'll go to next page, page 11. All right, page 11. Anybody still need this? All right. One thing I wanted us to do is see. So number one, we're just relying on the same identities that we've seen before. Okay, look at the left side here. Left side is in terms of sine and cosine. The right side is in terms of cosine with the sign that is sticking out. So I'm thinking, well, I have to save a sign. That's part of what I need to produce. So I can do that here, right? What if I just go ahead and pull a sign out in front, save it, see what happens next, because I know that the remaining expression is going to have to be this in terms of cosine. So I'm going to just pull a sign out from the sine to the fifth. I know I have to save it. So if I remove a sign from this expression, I'm left with what? Sine to the fourth, okay? Okay, so little by little, we need to basically convert this remaining expression all to be in terms of cosine. Well, cosine squared is already good to go. It's that sine to the fourth of x that we need to work with. Okay, so we have an identity for sine squared. We don't have an identity for sine to the fourth, but what we could do is we could at least get some sine squared to show up. What if I made it sine squared squared? Right, they mean the same thing, but at least I can get something that I can use. Right, does that make sense? I'm trying to rewrite it in a way that will fit with the identity that I want to use. Okay. Does everybody see the logic from the first to the second to the third step? Okay, so we're almost there, actually. We know the sine is already finished. We know this cosine squared. Okay, it's already in terms of cosine. It's just this piece we have to resolve, right? And what can I replace sine squared with? 1 minus cosine squared. Okay, so after that, it's just a matter of expanding all the way out to make it look like our answer here. Okay, good so far. Okay, so really we just have to work with that middle term, right? That middle term, careful, we can't just distribute that exponent through. You have to write it out twice so you can remind yourself that there's a foiling process going on there. So I'm going to rearrange it, put the sine x and cosine squared, because I know that they're done. It's just this one last piece I have to expand out. So I'm going to deal with the parentheses. And once that's done, I can worry about what to do with the other piece of cosine. But okay, so careful that we write it this form so that you're reminding yourself the middle terms. Otherwise, if you just distribute the exponent 2 through, you're going to miss out on some stuff. Okay. One minus cosine x minus cosine x. Okay, so each step that I take, I keep looking at my goal, right, to see, am I getting closer and what's my next step? So we're actually just one step away. What's the last thing that we can do here? Oh, wait, let's see. Did I miss something here? My bad, guys. Here, I need to write this out as 1 minus cosine squared times 1 minus cosine squared, right? Because there's two of them. I left that exponent out, which means that all this has to be changed as well. This is 1 minus cosine squared, and this is what? Cosine to the fourth. Yeah, sorry about that. Okay, that's better. Okay, what's our final step here? Good. Yeah, distribute the cosine squared. We should be able to make it match our conclusion, our right side here. Minus 2 cosine to the fourth. All right, we're just adding exponents here. Okay, number 2. Number 2 has a similar feel to number 1. Maybe it's a little bit easier. I look at the left side, sine and cosine. The right side is just in terms of sine. It looks like there's a cosine that is saved. So I'll do that on the same side, on the left side. I'll just go ahead and save a cosine. I know that's going to just be left alone because it's going to have to show up in my final conclusion, my concluding statement. So I'll just go ahead and pull that cosine out in front and make it sine cubed times cosine squared. Okay, so I'm saving a cosine because I'm looking at my end result. So if I take a cosine away from this cosine, I'm left with cosine squared. All right, what do you guys see next? Good. Get that cosine squared in terms of sine, and we should be home free. Okay, we're almost there. Just distribute the sine through, and it should match the right side. Number 3. I think it's going to be another one of those common denominator problems. What's our common denominator for number 3? Good, yeah. So those are 2 separate pieces. We need to include both to create our common denominator. Okay. Okay, we'll balance each fraction. This first denominator is missing the 1 minus sine x, so we need to include that. We'll distribute that cosine through a little later. The second fraction is missing a 1 plus sign. Distribute that as well. So my next step is to distribute through and push those fractions together. Okay. Any cleanup that we can do here? What do you guys see? Numerator. Not yet. Okay, not yet. But denominator. After we combine the denominator, we should be able to make that happen. But the numerator, I'm just trying to see if I can do some cleanup with the numerator. So I see those cosine signs can go away. So the numerator, I'm left with plus cosine plus cosine. 2 cosine. Okay, I'm looking at my end result here. I want my end result is in terms of secant. We know secant is related to cosine. So maybe I can get some cosine to show up. What can I do with this piece here? If I expanded this out, what's gonna, you know what this is gonna turn into? Let's see what happens. This turns into 1 minus sine squared x. Does that ring a bell there? Yeah. So that actually, right, if I expanded this out, this is going to turn into something that I can use with Pythagorean identity. Get that to turn into cosine squared, and that's good because we know secant is related to cosine, so we should be able to get something to happen there. Okay, so everybody good with that connection there? So now that we have cosines above each other, we can take one out. We're left with 2 over cosine. Are we at the end here? Yeah, cosine is the reciprocal of secant, so I can just make that come up. Nice. Before I do number 4, let me walk us through something. I want to make a connection with you in terms of factoring here. So before we do number 4, let's step to the side. Have you guys? I want you to see something here with factoring. Okay. Okay. So if I ask you to factor this, x squared plus 3x minus 4, how would you factor that? Yep, you can split x squared into x and x. Well, there's no GCF, but we can go straight into factoring in the sense that we ask ourselves what multiplies to be -4 and adds up to be 3. Okay, so +4 and -1. Okay, easy factoring problem, right? Multiplies to be -4, adds up to be 3. Let's double check. 4x minus 1x is 3x. Okay, now I want you to apply what you just did with this next problem. If I gave you sine squared x plus 3 sine x minus 4, would this feel the same to you here? What can I break that sine squared into? Sine x and sine x. I'm still going to ask myself the same question. Would multiplies to be -4 and adds up to be 3? +4 and -1. It looks a little messier because your variable is not just x, it's sine of x. But it looks messier, but it's the same problem, right? You guys know how to do. If you know how to do this, you're just making a substitution and and doing it in terms of a trig function. It could be sine, it could be cosine, it could be tangent. Okay. Are you good with that connection there? Okay. So let's turn to number 4 here. So number 4, I have something that has that relationship there. I got a squared, I got a cosine, and I got a constant. So I'm going to rearrange this numerator in a form that maybe is a little bit easier to work with. I would like that cosine squared to be first, just for factoring purposes. But I hate factoring with my first term being negative. So I'm going to factor, I'm going to take a -1 out. If I take a -1 out, I can just think of this problem as adapted with my first term being okay. I know factoring in trig function feels a little intimidating, so why don't we just pretend like it's an easier problem? Why don't we think of it as, okay, can I factor 4x squared plus 3x minus 1? Okay, if you need to see me do that first, and then you can replace cosine in for x, you can. So let's just do an easier problem. All right, if I ask you to factor 4x squared plus 3x minus 1, that leading coefficient is kind of a different process, but we can always make this into an easier problem, right? If I push that 4 to the right side, it's really just x squared plus 3x minus 4. I'm just multiplying 4 by -1. Factor this out, multiplies to be -4, adds up to be 3. I get x plus 4 and x minus 1. However, there's that leading coefficient. We got to deal with that, so we have to divide by 4. Reduce. If you can. If you can't reduce, you pull it out in front. I get x plus 1 and 4x minus 1. So this is factoring in terms of x. So if I do factoring in terms of cosine, I can just replace x with cosine. So you can always do that. If you want to just, you feel like you recognize it's a factoring problem, maybe you want to factor in terms of x, and then once you get that, then you bring that trig function back in. Okay. If that feels easier, then you're welcome to do that. Okay. Looks like everything on the right side is in terms of cosine. So what can I do with that sine squared? Okay. So sine squared can be turned into 1 minus cosine squared. And what can I do with 1 minus cosine squared? To make it match a little better with maybe this piece here. Difference of squares, right? Factor. So I can split this up into 1 minus cosine theta, 1 plus cosine theta. Okay, any matching parts? Are these the same here? Yeah. So I think we're at the end, right? Just if we distribute the negative through, we can make it 1 positive and the cosine being negative. yeah, it's the same thing. I just have the 1 and -4 in different order, but the 4 is negative and the 1's positive. We know we're at the end. Okay, number 5. Secant to the 4th. We don't have an identity for secant to the 4th, but we do have an identity for what? Secant squared, right? So why don't we make that something secant squared related? So I can just make it secant squared squared. Or better yet, just make it secant squared times secant squared. Okay, we already have a part of the end result. We can just turn the other secant squared to what? Yeah, Pythagorean identity, right? 1 plus tangent squared.
Can I get a pass?
Okay.
It's 5, 2, and 5.
Mm-hmm. Okay, have a good weekend.
You do.
Okay. Questions with 5. Okay, on to page 12. You guys try 1 through 4. I feel like these are pretty straightforward. So try 1 through 4, and I'll go over them with you. I'll put a hint for number 3. Number 3 is a factoring problem, but just think about this. If you can factor x to the 4th plus 2x squared plus 1, sorry, then you should be able to adapt that for something that's in the form of tan to the 4th x plus 2 tangent squared x plus 1. Okay. But for number 1 and 2, just think about GCF, right? Factor the GCF out, and you should be able to get some trig identity to show up for you. Okay, so page 12, we'll just have you try 1 through 4, and then we'll be done for today. Yeah, so with these, we really don't have a right side to match up with. We're just trying to get it as cleaned up as possible. See if you can get it all the way down to in terms of like sine or cosine. GCF for number 2 feels like number 1, factor the sine squared out, put the remaining pieces inside a set of parentheses. I've got identity that I can use here, secant squared minus 1. It's just tangent squared. I think that's as far as we can go. Right. If I make this sine over cosine, I can't get anything to cancel out, so. Okay, so I'm number 3. Just if you can think of it as an easier problem, instead of tangent, you use x. This is not too bad, right? Multiplies to be 2. Sorry, multiplies to be 1. That's to be 2. So this is really x squared plus 1, x squared plus 1. And if you can see that relationship, then we can basically just replace x's with tangents, and we have our factor form. What's tangent squared plus 1? Secant squared, yep. Secant squared, we get secant to the 4th. Okay, one last one here, number 4. Sine to the 4th minus cosine to the 4th. Do you see anything here? Yeah, perfect squares, right? Difference of squares. Let's break them down. If I have a squared minus b squared, it's just, well, in this case, a to the 4th minus b to the 4th. We just split them into their separate perfect square roots, and then one's a minus and the other's a positive. Okay, see anything? Just one of them though, right? This becomes 1. The other one we can't do much with. Okay. All right, show me page 10, 11, and 12. Oh, I factored it out first, and then I converted all my cosine to cosine. Oh, okay,
yeah.
and then I made that cosine over sine. First, you see that there's a sine square here. So if I take a sine squared out, that means I'm dividing by sine squared. So you should It's because of this. So I factored cosine squared out, which means I'm dividing cosine squared from both of these. This divided by this. But then cosine, yeah, this becomes 1, so I'm left with cosine squared.
One minus.
Yeah, 1 minus cosine squared. Right.
Yeah. Well, and I can go to and so I will.
That's right, ignore that part. Yeah.
All of a sudden. One of the answers.
Yeah, so,
Like a good answer.
no, the domain is still good. Domain's still good, it's just that when you get down to here, you don't have to provide a line value.
Just literally touch on all of the words. No, it's just